If you haven't done so yet, please pause the video and try the question on your own before listening on. Our first step to solve the question is to draw a free body diagram of the charge Q1. We'll notice that there are three forces acting on that charge. You have the downward gravitational force, symbolized by mg. We have the tension in the rope pointing upward, which is holding the charge up. And then we have this downward electrostatic force that we've called Fe. Now the reason for the electrostatic force is because the positive charge is located very close to this negative charge Q2, and since they're oppositely charged, Q2 is going to pull down on Q1 with an attractive force. So we've shown that in the free body diagram with the Fe. Now, because charge Q1 is in equilibrium, we know that the sum of these three forces will equal 0. We'll go ahead and plug in the forces. Notice that both mg and Fe are pointing down and are therefore negative when we plug them into the formula. Now, if we look at part A, it's asking us to find the tension in the string. So we're going to solve this equation for T by adding mg and Fe to the right side of the equation. We know from this chapter that Fe, the electrostatic force, is equal to the following expression. We have the Coulomb constant K times the absolute value of charge 1 times the absolute value of charge 2 divided by the distance between the charges squared. So we can replace Fe with this expression here. And now we're ready to solve for T by plugging in all the known values. Just be sure that you change the values to standard units. So for example, the mass was given in grams. We're going to have to multiply that by 10 to the minus 3 in order to convert it into kilograms. The charges are both given in nanocoulombs, so we'll have to multiply them by 10 to the minus 9 to get it into coulombs. And then the distance was given in centimeters, so that needs to be multiplied by 10 to the minus 2. So we've plugged in all the known values. If you need to, you can pause the video and just make sure that all the numbers go in their respective places. When we crunch this down on our calculators, we get approximately 0.115, and then the unit will be in newtons because tension is a force. So we'll use the newton as the unit. So there is the correct answer to part A. We can move on to part B now. Now in part B, we have essentially the same setup, except now we are given the tension T, and we are being asked to calculate the distance d. So we have the same equation that we used before. We can replace Fe with the Coulomb's law force. And now we'll make an attempt to solve for d. It might help to put brackets around this term. We'll notice there's a minus sign in front of it, so it can be added to the right side of the equation. We can next enclose this entire t minus mg in parentheses, and what we'll do is we'll multiply both sides of this equation by d squared. That way the d squareds will cancel on the right side here and here. We will next divide both sides of the equation by the term t minus mg, and again they'll cancel on the left side. And then to finish solving for d, we'll take the square root of both sides of the equation. And we're now ready to plug in all the known values. Remember that the tension T was given to us as 0.18 newtons in this question. So all the known values are plugged in. Once again, please pause the video and just make sure all the numbers are in their respective positions and that it makes sense. When we crunch this down, we get roughly 1.25 times 10 to the minus 2, and then here we'll have the unit of meters since we are calculating a distance. Thanks for taking the time to watch the video. If you liked it, please subscribe to the channel so you could stay tuned for additional videos. Also, you are welcome to send in your own question to the email address shown on the screen.